Hi guys, in this video we are going to take a look at this question. So read this question once, okay, and then we'll see, okay, how to solve this. So what they are saying in the question, they are saying that, okay, a block of mass m, it is kept on a moving block of mass capital M in such a way that capital M moves but m remains at rest with respect to m. So then you have to tell which of these is the correct answer, right? So just read it, okay? I'll wait for a minute, okay, and then tell me which particular question, which particular answer is correct. Okay, so let's see how to solve this question. So they say that a block of small m is kept on a moving block of capital mass m, and they are saying, okay, one of these options is correct. Okay, so first is momentum of mass small m must not be zero in any frame. So they are saying must. Okay, we'll see. Kinetic energy and momentum may be zero in a frame. Okay. Third option, momentum of m must be zero, must not be zero in any frame. And D is none of the above. Now, see, the question is, okay, must and maybe, okay, one of them. So if you see, okay, we have a block, okay, of say a wedge of capital M, okay, and we have this small m, okay, mass, okay, here. Now this particular, okay, system may be moving, okay, with some momentum, okay, say some velocity, it is moving in the forward direction, okay, this whole system. Now it could be possible, okay, that this block small m, okay, is at rest, okay, that is a valid situation, right? This so what will happen? So this wedge will move, okay, so this wedge will probably, okay, move here, okay, it will come here, okay, but this block of mass m, okay, remains where it was, okay, with respect to the wedge of capital M. So we can say, okay, that small m can be at rest, but with respect to frame of reference of the wedge, that is capital M. So small m can be at rest with respect to the wedge, but small m is actually moving, right? It is moving in this direction with velocity v if you're considering ground as the frame of reference. But with respect to capital M, it can be at rest, okay? If you're considering the frame of reference as the wedge. So this thing is definitely wrong, okay? That momentum of M must be zero in any frame. No. If the frame is the wedge, then it will be 0, but otherwise no, okay, otherwise with respect to ground it is moving, so momentum will not be 0. Kinetic energy and momentum may be 0 in a frame. Okay, they are not saying must be 0, okay, they are saying may be 0 in a frame. Yeah, so if you're saying, if you're considering wedge as the frame of reference, then of course we said, right, it is at rest, so it is at rest or its velocity is 0. So if velocity is 0, then kinetic energy, okay, half mv square will also be 0, and your momentum mv, okay, that will also be 0, because why? V is 0 with respect to wedge, okay, as the frame of reference. Now if you say momentum of m, so this can be correct, right? One option is definitely correct. Then momentum of m must not be 0 in any frame. No, that we just discussed, right? That momentum of m can be 0, okay, momentum of m will be 0 if the frame of reference is capital M, right, or wedge basically. So this option is also not correct, okay, and this was also not correct. So none of these will not be the correct answer because we got one option correct, right? So our answer is kinetic energy and momentum may be 0 in a frame, right?